I'm a member of the ACM, also a member of the CAT. If you guys need help with anything, just come and get me. Today we're going to go over the very basics of using Git. So kind of as a broad overview, we're going to go over the history. We're also going to talk about the basics of implementing it for your personal day-to-day uses and then how it's useful. Okay? So Git came about when the guy who wrote Linux, so this Linus Torvalds, he actually wrote Linux. And in order to do that, there was a program called BitLocker that was proprietary, and it was apparently so bad that he wrote his own version control software, and that was Git. So version control allows you to not only work on this and go back to any previous part, it will also allow other people to do that. So kind of in a broad strokes of what's happening is you're going to have a master that's on a server. And then you're going to pull down from master your own personal version. And you're going to make modifications. And then before you send it up to master, we're going to do our personal testing and whatever. And then you're going to request a merge. So everybody can be working on it at the same time. And then they're all going to go to master, and then everything's working. So the little tiny piece that I'm going to do is the little part that is not involving master. You're going to actually just be doing modifications to your own branch, but that's all you have to do. Now the beauty of this is you're going to give it a description of your personal version at a snapshot in time. Any modifications from then on, you can go back to any point in history. And it's actually very simple to implement, but it would solve a lot of problems such as, oh my gosh, all of a sudden nothing compiles and I don't know where the mistake was. Or I flipped the arguments when I tried to tar something to turn something into an assignment. What do I do? Okay, any questions on that so far? Okay. Okay, so some basic Linux commands. What I wanted to do is, if you want to change the directory, you're going to use CD. If you want to list what's in that directory, you're going to ls. If you want to copy something, you want to copy, or cp. If you want to make a new folder, we're going to make a directory. So if any of those are unfamiliar with you, do take notes. We are going to be playing around with stuff. Is everybody okay with Vim? Okay, that's probably how we're going to be modifying text files. If you want to get cheat sheet, you're going to copy what is right there. So you're going to copy, you're going to use the R flag to say everything in that folder I want a copy of. And you're going to go to //acm/git_class space tilde. The tilde is a shortcut for your home directory. So what that is saying is I want you to go out to this place and copy everything and copy it to my home directory. Let me see if something happened. Okay, so I've now created a new file, and I'm going to say there is now stuff in this file. Okay? So if I now do a cat and test, we now know that there is now stuff in that thing. Okay? Now, okay, everybody have a thing? Mm-hmm. Okay, now we're going to say, hey Git, I want you to track this thing. So we're going to call, so underneath the create file, it's going to be add. So we're going to say git add, and then you can either do one of two things. You can say, I want everything here. That is the easiest way to do a Git file, is I want you to add everything. We're going to touch on this a little bit later, but right now we're just going to say, I just want you to track my test.txt. Okay? And it says, I've modified things. Okay? If you've been in my prior classes, you will see that we're on branch master and it's now modified. If you haven't, come see me and we can go over how to make that appear on your thing, because that is very handy once you start using Git. Okay? So the final thing is we're now going to do a git commit. Okay? Now, we have said, hey Git, I have a file here. This version right here, I am now committing to your memory. Okay? But you're going to need to come up with a descriptive identifier. Your very first one is usually along the lines of, oops, first commit. You could also say something about, this is a test, or something else. First commit is usually just fine. And then you've got a whole lot of other stuff that you're on branch master. This is the initial commit. And then the changes that are there is we're actually creating test.txt. Okay? Yes?
I'm just curious, like, where this text, I'm just guessing you created this ahead of time?
No, this appears. This is now a Git repository. And it will be clear later, but this will all pop up automatically.
Okay, gotcha.
So you create a new file, you do an add, and then you do a git commit. This will automatically pop up. All you are doing here is giving it a descriptor. This snapshot of the file, or of the files that you are being saved, that show up here, you're going to have a commit message. That's what we're doing here. So that later on, if you ever need to go back to this version, you can zero in on what you called it. Mm-hmm. So later on, you might say, this implemented the counting loop. This is taking user input. This closed a bug of some such. So that when something breaks and you are going, oh my gosh, or I think I'm done, that one's very impressive. I think I'm done, or this compiles. This does not compile is also very valid. Just these are for you, so don't think this is a hard and fast rule for now. This is for you. Whatever makes you be able to go back to this version and know exactly what has happened between this commit and the last commit, it's all for you. Okay? So we're going to go ahead and save and quit. So we have now changed that, and we are good to go. All right? So we have actually said, hey, Git, this snapshot has now been saved. So now go back into your tests.txt. And now we're going to add more stuff. Okay? So it looks like that we only have one, but we have made changes to the file. So now we're going to do the same thing over again. We don't need to do an init because it has already been created. The file has already been created, so we just need to add it again. So git add. And then what's going to be the next command? Git commit. Okay.
So it commits all the added files?
Yes. So add is going to say, this is what I want you to add. So if you create a new file, let's say that was a CPP file. And then you split off and do a .h file. Let's say you don't want to commit one of those for this snapshot. You'll have it listed. Okay. So this one will be, oops. Okay, so now we have another descripted. So now we have our original version. So let's say we've got our initial test.txt, and we've saved that as a snapshot. We've now switched over to the next version, which is a test.txt of our current one with more stuff in it. Okay, so we can go and look at what has been modified by doing git log. Okay? So this gobbledygook here are actually hashes of the file at any specific time. Okay? So our very first commit is the last thing on here. And that was this is why that message is so critical. Because it's very easy to use this or this to zero on where you want to go back to. So we've got more stuff. And notice how it says, hey, this is where we are right now. Does anybody have questions on that? I know it's kind of unclear, but this is the order. This is the critical part. If you can get the add and commit stages down, you can go and get help from anyone and say, I don't know what's going on, please help. Because having your snapshot saved is 90% of the solution. So for every function, every tricky part you finish, go ahead and just create a real quick snapshot. It's going to be super quick once you get down and going, because you're just going to say git add dot and then git commit. And you can even shortcut so it doesn't go to the other screen. You can use an M flag to say, here's my message. So in two command lines, you're done.
So this is something we could do with like our programming assignments? Like,
This is why I'm telling you this.
like exactly why?
This is exactly why this is, I wish I could push it up, but the other classes are on the critical side. And this is actually vital for industry. You will be using the exact same stuff, just more in depth with more tools.
This just saves me making 15 copies to save version 1.
Exactly. So when I was going through this class, I didn't know anything about Git. What I actually did is I used rsync to save it to a file every time it would compile. So at least I could always draw back to my last compile. This, you don't even need to wait for it to compile. You can go back to the very beginning of when you first typed into a file. Every single time you create a new directory, go ahead and add that. And you'll be able to go back to any version. It's very, very powerful. Yeah.
Just wondering what the relationship of this is to GitHub.
So we're going to talk about that towards the end. So remember when it said an empty repository type of thing? You can actually link this to an offline or an online repository, and all of these files will now be over there. Right now, this is all stored locally. So remember how I was saying there's the master branch, and then you have your own personal local branch? Right now, I want you to get in the habit of just using the local branch. Once you've mastered that, you can start going to that one. But long story short, what it does is say, you have an excellent idea, but it's too much for you. So you come to me and say, hey, I heard you could code. Please code this. And I say, oh, okay. And you give me a link and say, here's my repository, push when you're done. And so what you're going to keep working on a function, and then I'm going to be working on an entirely different function, and then we're both going to push it up, and then you're going to decide kind of what's going to happen from there on. So you're going to see my push. I should have the function fully implemented, fully compiling, and you're going to just click OK. As long as everything works seamless, that's all you have to do is click merge. It's a big green button that says merge. And it's very fancy. But it is also scalable. You could have 100 files and everybody's working on their own different version, and then you could just push them all up at the same time and you're good to go. Okay. Okay. So one of the other things I wanted to shoot is not just the git log, but we're also going to talk about the git diff. So you're running around and all of a sudden your code is broke. Why did this happen? An easy way to look at it is a git diff. And what you can do is just copy and paste these two things. You don't actually need the whole thing, you just need enough to differentiate the beginning and the end. So we're looking at two different files, the first test.txt and the second .text. What was the difference between this one, which was this, which is currently considered master, and this one, which was our initial commit? It was this line right here. So if you have, when you're typing through Vim and all of a sudden a character got misplaced, you accidentally deleted one of the first slashes in a comment message, the star just suddenly got deleted, a semicolon suddenly got misplaced, a semicolon was added in the wrong place. You can now go back and look at what is the difference between the version I'm working on that's broken and every previous version. Okay? That is also very, very powerful. And you saw how easy that was to look at. And it will zero in between the differences. Okay? Does anybody have questions on this? Okay. Oops. Now, one of the things we're also going to talk about is the gitignore. I wanted to specifically kind of get it in your head. The gitignores are specifically for files that are not really useful to somebody. So one of the great ones is a.out. A.out is an actual program that will run on your local machine. However, if you go home, that a.out file might not work because it's done on a completely different machine. So what we can do is add a .gitignore. So this is actually a file that you're going to create called .gitignore. The dot at the beginning will make it invisible. So unless you use the -a when you ls, you won't even see it. You won't even know it's there. But Git will actually look for that file and see if there's any matches. If you want to get more into it, there's a system called regex, and we do that towards the bottom. So it just looks for copies or matches. A.out, it will look for any A.out. If you're changing your executable name, change it to that executable name, or some way so that you're not always saving it, because it's looking for changes. It wants to save everything, unless you specifically say, I only want this file. If you add it to a .gitignore, you can actually go, I want to add git add dot. I want you to add everything, and it will add everything as long as you've got stuff like this in place. Later on, because I don't know if you're ever going to get another class on Git. When you're creating a repository, config files will hold passwords, API keys, SSH keys, vital information that if it gets into the wrong hands is very, very bad. It takes about 17 seconds, apparently, from a paper written a month ago for a person to run through a Git repo and find API keys. It is very serious. Do not include your Git config files into your Git repo. Always, before you do something like that, go to .gitignore and put in your config files. Sometimes it says .config, sometimes it'll be something special, but I want you to always remember, if you're starting up a Git repo and anything like sensitive information is going to be in it, put it in your .ignore so you can't possibly accidentally save it. Okay? I have personally seen this being a problem, okay? So I can't harp on it enough, but if you're interested in security at all, remember that little bit. do not put a config file in your Git repo, okay? I know it doesn't matter now, but I can't stress it enough. All right, so these other two ones should look much more familiar. The .swap and the .swo. If you're going to use get, eventually you're going to create at least a .swap file. What that is it's actually a lock on that file that says, hey, I'm using this right now. So examples that this comes up is you've background Vim, you'll suddenly see a swap file, or you can close Vim or close your whole terminal window with Vim open. You'll generate swap files. If you do it a second time, you'll create a SWO file. Okay? Does anybody have any questions on kind of what's going on with that? Okay? Okay. Does anybody have any other questions? Because that's kind of where we got to. I know it was kind of shorter this time, but I also don't want to overload you guys with anything.